Very good morning to all. I am Dr. Muthukrishnan, Professor of EEE Department. Now I am going to discuss and handle the subject of power quality management. In this case, first I am going to take the topic of transient. Normally, the transient is nothing but switching stage. Maybe one stage to the another stage. Sudden changes will be takes place. In power quality, suddenly the voltage or current from normal value to steady state value is abnormal. Enormous voltage, enormous current will be appear. That is called the transients. Some other name technically we are using the surge. Have you seen into the top of the building on arresters will be there? That is called the lighting arresters. Nothing but simply you are telling this surge arrestor. The signal may be voltage or current will be there. So we are going to categorize. First we are going to the classifications of transient. First one is impulsive transients. Impulsive transient is nothing but suddenly takes place. Enormous signals will be takes place. Non-power frequency, that is very important. What is the frequency value? Non-power frequencies will be there. The signals conditions may be voltage or current, but only one case unidirectional. That is called the impulsive transients. So the meaning is suddenly will be appear non-power frequency and also unidirections will be takes place. So how we are going to characterize and how we are going to measure means rise time and as well as the decay times will be there. See this diagram, x-axis and y-axis as already told it's a unidirectional. In this case we are taking this negative side and the x-axis you are having this time will be there. So rise time will be very short period, enormous current is appear in terms of kiloamps, and similarly the x-axis decay times will gradually takes place for a particular period. It is called the transient, impulsive transient. And the next one is this oscillatory transient. The same concept, same definitions, but the direction is unidirectional, not unidirections, it's a bidirections will be there. That is called like I said DC. The previous case we are considering DC, in this case we are considering as the AC, like that. For easily understand I am going to tell this. Okay. Oscillatory transient consists of voltage or similarly any signals will be there, voltage signal or current signals is there, but whose instantaneous value, that is the bolded letter I am mentioning this instantaneous value changes the polarity. Why I am mentioning this instantaneous value means because it's a unidirectional. Obviously we can consider as a AC signals will be there, whereas AC signals is so many parameters, so many quantities, that DC is only one quantity. For example 5 volt, 10 volt, 5 amps, 10 amps means steady states will be there, but whereas AC signal is nothing like that. Positive side, negative side, it may be sine wave, square wave, short tooth wave, any type of wave will be there. So obviously from 0 to increasing the maximum value, again coming to 0 and increasing reverse directions, reverse maximum again comes to 0. It may be square wave or sine wave, anything, the shape is like that. So which type of value we are going to take when we are considering this transient is a oscillating transients, means AC signals means it may be RMS value or average value, peak value, instantaneous value. Normally for calculations purpose in our India we are taking this AC is the RMS value, but in this case we are taking this instantaneous value. Why means at a particular instant the surge signal will be appear. So at the time enormous maximum peak values of voltage and currents will be there. So that's why I am taking this instantaneous value we are considering for this case. Again how we are going to characterize or measure? Obviously on x-axis and y-axis. X-axis we are taking this time, y-axis we are taking this magnitude is value, that is called the durations and also the magnitude is there. See this diagram, x-axis we are taking this time and the y-axis taking this magnitude, the signal voltage or current. So the frequencies positive side and negative side, the signal is, that is already told the definition. By definition the unidirections will be there, high frequency, medium frequency, low frequencies we are going to appear. Next we are coming to the long duration voltage variations. So we have completed the transients. We are very clearly transient is nothing but suddenly change in the voltage or current. What is the reasons means because of lighting. Two categories there, one is the unidirectional category and another one is this bidirectional oscillatory impulsive. Now we are going to discuss about this long duration voltage variations. The duration will be long. voltage has to be vary, maybe increased or decreased. That's why I are giving the title is very very clearly long durations, time with for a particular period, that is called the long durations. Voltage variations will be there. Encompasses RMS value, root mean square values, deviations for power frequencies longer than 1 minute. So the bolded line has specified longer than 1 minute. So the voltage variation is more than 1 minute means we will consider this is as a long durations voltage variations. So again, which signals I am going to take this RMS value. So we know the peak value means RMS value can easily calculated. So ANSI C84.1, ANSI is American National Standard Institute. So obviously this is one forum, this is give some definition, some bylaws. According to that ANSI C84.14 means specific means it gives this voltage variations increasing or decreasing time period more than 1 minute. This ANSI defines more than 1 minute, we can consider as a this is the long duration voltage variation, maybe over voltage or under voltage. That's why I'm giving the voltage variations means normal value, maximum value greater than or less than normal values will be there. First you are taking this under voltage, and voltage is decreased RMS value less than 90 percentage. That's very very important things. Less than 90 means we are discussing voltage variations. The voltages I am taking 100 voltages, 90 voltages, that is called the 90 voltages. More than 1 minute means this is called this under voltage variation. Under voltage variations are what is the reasons for the causes is very very important thing. What is the reason means under voltage variations will be there. Capacitor switching off, capacitor bank switching off, or causes of under voltage. What is the reasons for capacitor switching off? How it will come capacitor? Because of load plays an important role in your consumer side, especially small scale household and small scale is there is no any problem. In case if you are having this large scale industries like I said textile mill and cement mill, paper mill, we are having so many departments. For example, we are considering the textile mills from the starting itself. Mixing will be mixing department will be there, blow room department will be there, guarding department, drawing department, so many department, spinning, cone many department. Each and every department they are having own process will be there. Initially we are giving this cottons and step by step so many process, so many department crossing. Finally we are getting this some thread like this, some products we are going to take it. So each and every departments they are having own loads will be there. It may motors, which type of motors means AC motors and DC motor. Normally the textile side means they are using this AC motor. What is the purpose means we are using the AC motor means maintenance is very well. Similarly the same concept we are going to use this paper mills or cement factory mills, they are preferring this DC motors because compared with AC motors the efficiency is somewhat good, so that's why they are preferring. But one more thing is the cost is too high. So we are having this at the time we are taking this power factor plays an important role. So obviously when the power factor is poor means we have to use the capacitor. Why I am telling this? Power factor is nothing but the angle between voltage and current. Cos phi equal to kVA equal to kW divided by cos phi. If the cos phi values increase means obviously the kVA value will be decreased. So power factor is 0.7, 0.8 means we have to increase the 0.9. So then only the kVA will be reduced, or otherwise we have to give more amount to the electricity board or the tariff will be high. So that's why we are using this capacitor. So for our purpose, for our benefit, we are using the adding the capacitor. So how it is possible? We can use the switch, the capacitor has to be added existing with the load. So obviously the power factor improve, but at the same time the voltage has to be, disturbance will be takes place, voltage has to be reduced. So that is called this under voltage, they are telling this. So this is the purpose you are using the word is using capacitor banking switching off causes and under voltage, they are telling this. So why we have to use the capacitor means Already I told like this to improve the power factor itself. So suppose if you are not using the capacitor, so entire capacitor bank is there. We are considering this entire capacitor bank, so it is not advisable. So each and every machine you have to a small capacitor bank. So for a particular department, I am using one particular capacitor bank. After that, you are using this another department, some particular capacitor. Each and every capacitor bank is independently. So based on this load, we are adding this particular capacitor bank and we are removing the particular capacitor bank. So each and every time we can switch on or switch off will be takes place. Obviously, switching actions will be takes place. The capacitor is adding and removing, but under voltages will be appear. And another one is sustained interruptions. The interruptions, the voltage has to be interruption means voltage value should be zero, sustained for a particular period. So consider the AC waveform from 0 to the maximum value, again coming to 0, it reaches the negative maximum, again coming to 0 for a particular period. Each and every time the signal crossing the 0, immediately maximum 0, negative direction should will go. But suppose if it takes some times, if it stay the particular signal, that is called the sustained interruptions will be there. So the period is excess more than 1 minute, that is called the sustained interruptions. That means the signal is 0 for a more than 1 minute, the signal voltage or current, if it is 1 minute, that is called the sustained interruptions will be there. Longer than 1 minute out permanently, suppose if it is more than 1 minute, my signal is 0 signal means consider as a sustained interruptions. Obviously human interruption will be takes place, or otherwise if it is less than 1 minute, automatically it resumes, signals will be there. And another one is this outage. Again one more forum is there, IEEE Institute of Electrical and Electronics Engineers, they are giving the signal the rule values 100. This is giving the definitions for the sustained interruption. Next, short duration voltage variations will be there. So we discussed long duration voltage. Next we are coming to the short durations voltage is there. So for a particular period, the voltage has to be increased or decreased for a particular, that is called the short durations voltage we are telling. Each type of variations can be designated instantaneous, momentary, temporary. We are having 3 or 4 categories there. Instantaneous voltage variations, momentary voltage or temporary voltage, depending upon this how long it will take, durations, time. Based on the time we are going to classify this. The short durations voltages are caused by this energizers of large loads, high starting current, loose connection is there. So short, the previous case long durations voltage variations, but in this case very short period the voltage has to be vary, increased or decreased. What is the reasons they are giving this energization of load? Suddenly I am going to connect the load, I am going to remove the load. As already I told, the process is continuously going in your big companies. For a particular department, I want rest, I want to switch off means no problem, again I am going to switch on means suddenly they increase the load. Similarly, high starting current, whenever we are using this induction motor, any other motor means DC motor means we are suddenly start means starting currents will be huge. So at the times the interruptions will be there, that is called short. Again it comes to for a particular period the starting current is very high, comes to 0. Not only comes to 0, comes to normal positions. So at the times the voltage has to be increased or decreased, normally it has to be decreased. And also the loose connection, this is very very important things. Whenever loose connections appear in the main board side, distribution board side or terminal side, motor terminal side, loose connections appear means definitely the voltage variations will be there. Our supply voltage is good, if sufficient, but the loose, because of these conditions, especially the loose condition, means the voltage has to be varying depending upon the fault locations where the fault is appear, the system conditions. The fault can cause either temporary voltage, that is called, I told you the temporary voltage is voltage drops, voltage has to be dropped 90% voltage, 85% voltage, that is called the sag. Similarly, the voltage has to be increased due to some reasons, swell or a complete loss, interruptions. There are 3 categories there. One is the voltage has to be dip will be takes place. Similarly, the magnitude is somewhat less compared with your normal value. And another one is swell. The magnitude of voltage or current has to be increased more than 100%. That is called. And another one is complete loss, comes to 0. Next, we are going to take this interruptions. So, just an interruption can occur. The supply voltage or load current decreases less than zero point 0.1 per unit, not exceeding 1 minute. So, the interruptions will be appear. Obviously, the voltage comes to zero. Some interruptions will be takes place. The time durations first. The important things time durations not exceeding 1 minute. 1 minute, under the 1 minute we can consider as the interruptions, but the magnitude, one is time and another one is the magnitude, means zero point 0.1 per unit. We know why you are using the per unit. Per unit is nothing but actual value divided by base value. You are having this, so the maximum values. So to avoid this the calculations problem, we are using this per unit value, less than per unit. Obviously you are telling this 10 percentage, that is called this per unit. You are going to take this one. So interruption can be a result of power system faults, equipment fails, and the control malfunctions. So the previous case is voltage variation, means we are telling this, it may be voltage load has to be increased, or voltage load has to be decreased, switching operations, and the capacitor adding and the capacitor removing. But the interruptions means this is also one type of disturbance. The voltage has to comes to zero or less, reduce the maximum value or increase the normal value. So in this case, power system, what is the reason for result of power system, equipment failure, and the control of malfunctions. So these are the reasons for the interruptions. So with these few topics, I am going to conclude my lectures about the transients under the title of power quality management. Thank you.